Hi, today we are going to talk about basic parts of a quadratic function and review that part. So go ahead and find this in your cheat sheet. Okay, it says quadratic functions. So today we're just going to talk about attributes and like kind of transforming them a little bit. So standard form of a quadratic function is ax squared plus bx plus c. Okay, and then if we're trying to graph it, we would do like f of x or we do y equals. Okay? And then the graph is the curve, and we call that a parabola. Okay, so just some basic features. We're going to look at them visually and then kind of just write it out. Okay, so first we have the y-intercept, okay, where it crosses the y-axis. So the y-axis, so A, this would be your y-intercept, and we'll just label that A. Okay. Then we have our x-intercepts. We also call those our zeros, and that is where it crosses the x-axis. So with a lot of quadratics, they'll cross sometimes twice. So these would be called our x-intercepts or our zeros. Okay. There also could be a graph where it crosses one time, 1 0. Okay. Or it could cross no times, which would be 0 zeros. Okay. Then we have the vertex of a graph of a parabola, which would be right here. Okay, and that just kind of labels your highest point or your lowest point. So looking at this one, this is the lowest it gets to. Okay, so this is the highest or the lowest point. Okay. And then finally, we have our axis of symmetry, or our AOS. And it's that vertical line that passes through the vertex, and it's just basically where it makes it symmetrical, and that would be labeled D. And the way we can algebraically find that is doing negative b over 2a. Okay, so then we basically just translated and dilated them a bunch, and again, we can use Desmos for a lot of these. So looking at just the parent function, which is just a basic x squared, okay, if I add something to the end of it, okay, that does, it shifts it up and down. So those are called vertical shifts. Okay. And if we add something to the end, it shifts it up. And then if we subtract something at the end, it shifts it down. Okay. Then when we have something in the parentheses, that actually shifts it left and right. So we call those horizontal shifts. Okay, and we kind of have to like switch it in our brain since it's in the parentheses. So since we see minus, but it's in the parentheses, it actually shifts it to the right. And even though we see plus, it actually shifts it to the left. Okay. All right, then we had our favorite, which were dilations. Okay, so we can dilate things two different ways. We can dilate it vertically and we can dilate it horizontally. So if it has a value outside of the function, that is a vertical dilation. Okay, and so if I am vertically making the number bigger than 1, that means I'm stretching it, which means I make it skinnier. Okay, skinnier. Okay, and then if it's in between 0 and 1, I vertically am compressing it down, which makes it wider. Okay. Then if we dilate something inside the parentheses, that is actually a horizontal dilation. Okay. So if I horizontally have a number bigger than 1, it actually is compressing it down, which does make it skinnier if I compress something horizontally left to right, like inward. Okay, and then if I have a b value that is in between 0 and 1, that would be a stretch. I'm stretching it horizontally, which actually makes it wider. Again, I would make sure you try to probably write that down. Okay, then we have domain and range. Okay, so we have our domain are all our possible x values, and range are all of our possible y values. So looking at a graph, our domain for quadratics are all real numbers most all the times, unless we have different endpoints. And then our range, I'll write it kind of like this. Okay, we have to look at the y coordinate of our vertex. Okay. And then finally, we talked about vertex form. So again, we don't have to memorize vertex form. It's already given to us, but it's a parentheses x minus h squared plus k, okay, where hk is our vertex. And the a value determines which way the parabola faces. Okay, it also tells us if it's going to be narrow or wide. Okay, so for this one, we look at our vertex, so that would be 5, 2. Okay, our a value is 1, which means it would go up. So 5, 2. That means it would be a minimum, the smallest, and the smallest value it gets to is 2, which is our y coordinate of our vertex. Okay, for this next one, our vertex would be -6, -4. Okay, looking at my a value, -3, it's going to be pretty skinny. It's going to shoot down. Okay, so looking at this is the maximum. It's the highest point, and the highest point is at -4. Okay, so for today, we're just going to practice a few of these.